transformations, and we're actually looking at congruence transformations because we're not talking about dilations. We're talking about reflections, rotations, translations. So the first one you have is translation, which is a slide. So if I started with L, I can slide L this way. I can slide L this way. I can slide it down. I can slide it backwards. As long as I don't rotate it or reflect it, it is a translation. All you're doing is sliding left and right and up and down. So to write the rule for a translation, what we look at is the particular translation that we're given. So if this particular translation is translated 6 units to the right and 8 units down, that means we're going to go from our pre-image, which is XY, and that's our pre-image, from XY, and we're going to translate that 6 units to the right. That means X, that we're going to add 6 to all the X coordinates. And then 8 units down, which means we're going to subtract Y, 8 from all the Y coordinates. And that's your rule. And that's all you do for the translations as far as the rule. So if I give you a rule for translations, I may give you a rule and tell you to move the figure. You have to understand what the rule is and how to manipulate the figure. So let's look at reflections. All right, reflections. Okay. Reflections have a line of reflection. Reflections have a line of reflection, and that's like our mirror. So we're going to have a mirror with which we're going to reflect these things. So if I'm going to reflect a figure over the x-axis, okay, that means that the x-axis right here is my mirror. If I'm going to reflect it over the x-axis, then what I'm going to do is keep the x-coordinate stays the same, the y-coordinate goes opposite. So I'm going to reflect over the x-axis. Then the x-coordinate stays the same, the y-coordinate stays opposite. So I'm going to give you an individual example over here. Let's say I have the point 1, 3. That's your pre-image, and I want to reflect it over x. That's going to reflect to 1, -3. What have I done? I just took the opposite of y. Okay, so that's reflection over the x-axis. Reflection over the y-axis, instead of the x-axis being your mirror or your line of reflection, now your y-axis is. And for that, instead of the x changing, or the y changing, the x changes. Y-axis, y stays the same. X-axis, x stays the same. So if I were to draw another picture over here, let's say I have 2, 1, and I want to reflect it over the y-axis. That would come over here and be -2, 1. So what's happened? Well, this one, the x went opposite. The y stayed the same. So that's how you reflect over the x and y axis. Now let's look at a reflection over the line y equals x. Well, y equals x is this line right here. Has a slope of 1. That's our basic parent function. Okay? If I want to reflect over this line, all I do is flip the coordinates. So if I drew a graph out here, and I drew my line y equals x, and that's my axis, let's say I have a point there. That point would be -2, +2. Okay? In order to reflect it over the x-axis, the line y equals x, I just flip them. So instead of -2, +2, it's going to be +2, -2. And you can see how those are reflections of each other on either side. So that's how you reflect over y equals x. And if you're looking at the line y equals -x, that's this line. The slope is now -1. It's going this way. So I'm going to draw a graph. Draw my line of reflection, y equals -x. Let me label this here. Okay, so let's do this one. We'll make that -1, -3. Well, according to the reflection of y equals -x, not only do you flip them like you do with y equals x, but now they're opposite flips. So instead of -1, -3, We got positive 3, positive 1. And these are just rules that you're going to have to memorize. Okay, again, reflection over the x-axis, x stays the same, y goes opposite. Reflection over the y-axis, y stays the same, x goes opposite. Reflection over y equals x, they flip, xy becomes yx. And reflection over y equals negative x, they flip and change signs. So now let's look at reflections. Rotations. Rotations are when you actually take a figure and you rotate it, and you're going to rotate it about a fixed point. So you're going to rotate it around a fixed point. Now the origin is our fixed point for most of ours. We're going to be looking at the origin. So when you rotate something 90 degrees counterclockwise, that's the same as 270 clockwise, but we're always going to base off of counter. So 90 degrees counter, they flip and the y becomes negative. 90 degrees counter, they flip and the y becomes negative. Okay? So what was x is now here, what was y is now here, and it's opposite. If you rotate it 180, it doesn't matter counterclockwise, clockwise, you'll end up in the same place both directions. For 180, you just make them negative. So if it's 3, 4, this becomes -3, -4. And I'll give you some examples up here so you can see some examples. So if I have a point at 4, 3, and I rotate it 90 degrees counterclockwise, it becomes -3, 4. If I have a point 4, 3, and I rotate it 180, it becomes -4, -3. Okay? And then we've got one more, which is the 270 degrees counter, which is the same as 90 clockwise. You're going to flip them, and the x becomes negative. Notice there's a small difference between this one and the 70 degrees. And the 90 degrees one, the 90 degree one, they flip, and the y becomes negative. 270, they flip, and the x comes negative. So if you got that 4, 3 again, and you rotate it, you're going to end up with 3, -4. Okay? So look at these figures. We're going to look at number 9. Number 9 says, reflect the first figure in the y-axis and then rotate it 90 degrees. So let's do the reflection first. So we're going to do this one for number 9. We're going to reflect in the y-axis. So remember the rule, if we reflect it over the y-axis, the y stays the same. Okay? The y stays the same, and the x goes opposite. So if this point right here is at 1, 4, its buddy is going to be at -1, 4. All I'm doing is I'm finding the opposite of x. This one here is at 5, 4. So its reflection buddy is over here at -5, 4. This one is at 2, 1. This one's at -2, 1. This one's at 4, 1. This one is at -4, 1. So now that is step 1. I just reflected it in the y-axis, but I'm not done. From this point now, we are going to rotate it 90 counter. So there's how you reflect it over the y-axis, because the y-axis was your mirror. Okay, now we're going to rotate it 90. If you look at the rotation rules, okay, for a 90 rotation, it changes to -y, x. So let's start with this one. This one's at -2, 11. So I'm going to flip them and change the sign of the y. So that becomes a -11, -2. Sorry, 1. I don't know where I've gotten 11. I'm misreading it. Sorry. So we'll write these down. We got -2, 1. So that's going to change to, flip them, -1, -2. Okay, that's this one. Now let's do this one. -4, 1. -4, 1. Flip them, and turn the 1 opposite. -1, -4. That's the opposite. Okay. Now let's go to the next one. Let's do -1, 4. That's going to go to -4, -1. So those two match up. And then my last one is -5, 4. So that's going to change to -4, -5. Now if I connect that, that is your final figure. That's a reflection over the y-axis and then rotating at 90. So now let's look at number 10, last one. Number 10, we're going to reflect around the line y equals x, and then we're going to translate 4 left, 2 up. So let's reflect it around y equals x first. So I'm going to draw y equals x. That line goes right through here, okay? Y equals x. We're reflecting it in y equals x. Now the rule for that, when you reflect y equals x, is you just flip them. So look at this one. That one is at 1, 4. So its reflection, okay, is going to be at 4, 1. All right. Remember, reflections can overlap themselves. This one here, this one is at 2, 1. So its reflection is going to be at 1, 2. That's where its reflection is going to be. Okay. Then we've got this one. I know we've already used that 4, 1. Its reflection will be at 1, 4. Okay. And then we've got this one that's at 5, 4. So its reflection is going to be at 4, 4, 5. Okay, at 4, 5. So what you have to look at carefully when you graph these is which ones you are connecting. Well, that was a new one, 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 and that was a new one. So that is a reflection, okay? But we're not done yet. That's the reflection over y equals x. Now we're going to translate it 4 left and 2 up. So from my new point here, 4, 5, I'm going to go 4 left, 1, 2, 3, 4, and 2 up. So now my new point is going to be at 0, 7. I'm going to cross it out because I've already used it. I've got 1, 4. I'm going to go 4 units to the left. 1, 2, 3, 4, and 2 units up. 1, 2. My new point's going to be here at -3, 6. Okay. This one here, it's at 2, 1. 1, 2, 3, 4, and 2 units up. 1, 2. Okay. And then my last one was this one at 4, 1. 1, 2, 3, 4. Okay. And 1, 2. 2 units up. So now I've reflected it in y equals x and rotated it. Okay. And you're just going to have to study the rotation rules. And it's just the pattern. You just follow the numbers. Follow the numbers.